Okay, in the first hour of this lesson, okay, we will be doing Form 4, Chapter 3, and empirical, yeah, empirical formula experiment theory question. Okay, because this question is something that for sure will come out in your exam one. Okay, so guys, what is an empirical formula? Empirical formula is the formula that shows the simplest ratio. Okay, so the keyword here is the ratio of the substance. So like this table given, after your calculation, you're going to know what is the ratio between carbon atom, hydrogen atom, and also oxygen atom, the ratio of each of the element here. So in order to find the empirical formula, they will always give us the mass. Or I would say, you have to remember, in experiment, the first thing, I mean, the result that we got will always be the mass. I don't know whether you all did the experiment in school or not, the magnesium oxide with the crucible one, where you have to clean the magnesium ribbon with sandpaper, then you have to heat the magnesium ribbon until it burns. Got or not? You all did that experiment? Yes, right? Okay. So in the experiment, the result that you want to get is the mass. Okay. So in this question, they told me that carbon is 69.8%, while hydrogen is 11.6%, and remaining is oxygen. Okay, sometimes they will give you gram, mass, but sometimes they will also give you the information in percentage form. So just remember, giving you percentage and giving you gram, they are actually the same thing. When they give you percentage means the total mass of the substance 100 gram. So you can straight away, and you have to use the percentage straight away as mass. So please don't make a mistake here. Some of the student, or last time myself also did the same thing. When we see percentage, mathematics, every time we see percentage, or we like to like divide 100, then we go times something, like maybe we see, oh, they gave me the 172 here, I go times. No, guys, remember this. If you cannot remember, please write down like, okay, we reject answer. Okay, we reject answer, which is 69.8 over 100 times 172. We reject. That means when we see this, no mark will be given. So the correct answer should be straight away the percentage. 11.6. Remaining is oxygen. Okay, so how many percent is oxygen? How many? Yes, thank you very much. 18.6, very good. Okay, then now, after I got the mass, the ratio of each of the element here, ratio, is the ratio of the mole. So we must turn the mass given into mole first. To find mole, we use the formula mass over molar mass. Carbon is 12, which we did many times already in the past 2 weeks. I mean, this week and also last week. So this one, we're going to get 5.817, 3 decimal place at least. If you want to write 4, yes, you can write 4, but at least 3. Mass over molar mass, 1. So 11.6 mass over molar mass. 1.1625. Okay, then now, to find the ratio, guys, when I got all this, like, oh no, so, don't know what number is that, okay? And I can't even see the ratio. I can't even tell the ratio. What should I do the next step? So to find the ratio, we will always bring all the number downs. Yes, and then we divide them with the smallest one. So just bring everything down. And then we divide them with the smallest one. This is the smallest value of the three numbers. So everything divide 1.1625. 1.1625. And press your calculator. Okay, then okay, got it. Is our answer the same? Is our answer the same? Yeah, sure or not? Is our answer the same? Ah, sashimi, very good. Yes. Ah, you see? Ah, okay, good. Okay, guys, very good. The first one is supposed to be 5.004. Okay, 5.004. So here you see, 5.004 is actually 5. Not trying to trick people, not trying to trick people, because I tekan 5.187 just now. And then I see whether there will be people copying my answer or not. Okay, so 9.978. So guys, you see, whenever there's 9.9, we can round it off to make it 10 and then 1. So the empirical formula will be C5H10O. Just like that. Ta-da! Okay, and then now, we got to determine the molecular formula. Molecular formula. What's molecular formula? Molecular formula is actually just round up. Yes. Yes. Whenever it is close to whole number, it's like 9.9. The difference is less than 0.1. Okay, then we can round off. But if the value, guys, if the value is like let's say you got 2.5, or maybe you got 1.5, you can't round it off to 3, cannot. For 2.5 or 1.5, all this kind of number, you have to times 2 to make it 5. Okay. Thanks, Zachary. Very good. Molecular formula is the actual number. 5.8 need to times 5. Yes, you're right. If you got 5.8, you have to times 5. So actual number, which means the real formula. Empirical formula is the simplest ratio, the one being simplified already. C5H10O is our empirical formula. Empirical formula times a number will get us the actual formula. So what we have to do here is writing a working like this. C5H10O times a number to get back They want us to find the molecular formula. So for sure, they're not going to give us the molecular formula. They'll give us the mass instead. 172. So we just put the 172 in and also suck in the mass of all the atom here, C, H, and O. C5, H10, O times N, get me 172. Can anyone please help me to press the calculator? You should be able to get N equals to sashimi. Thank you very much. Thank you very much. Help me to press the calculator. Yes, Hauser, thank you very much. It's supposed to be equals to 2. Yes, 2. Very good. Okay, then, not yet. Okay, not yet the final answer. We still have to use the 2. I mean, we still have to sub the 2 in to the N. So C5H10O times the number 2. And this will get us the final answer, C10H20O2. And you can always double check your answer. Put in all the C, H, and O, and you're supposed to get back 172, like the one they gave you just now. Okay, so the total mass supposed to be equals to 172 as well. After this question, we have to go through the experiment theory already. Okay, next one. All good, all good. Find the number of mole. In 15.48 gram of this octylactanoate. So to find the mole, when mass is being given, we use the formula mass over molar mass. Mass is 5.48. Okay, guys. Then the molar mass here, am I supposed to use the C5H10O, the empirical formula, or should I use the this one 172 molecular formula? Which one? We use empirical or we use the molecular formula as molar mass? Yes, correct. Yes, we use the 172, correct. The molecular formula. Very good. Because that one is the actual formula. Yes, we want to use the actual formula. We doesn't want the simplified one. So in the end, we get 0.09 mole. 0.009 mole. That's all. Okay, that's all. Okay, guys, remember one question like this, finding empirical formula, finding molecular formula, the marks can be as high as 4 to 5 marks. Okay, so one package like this, 4 to 5 marks. Okay, then now this one is a different type of question. X gram of iron combined with 5.04 gram of oxygen to form an oxide with the empirical formula Fe2O3. So they already told me that the empirical formula final ratio will be Fe2 and O3. Iron is X. Oxygen is 5.04. Okay, so we do it like usual. Mass will be used to divide the molar mass. Fe is 56. There's no number here. But the other one, 5.04 divide 16 is going to get us 0.315. Oi, why is it lagging? You all can hear my voice. Yes, oh no, what's happening? Can you see I'm writing? No, cannot see. Ah, ah, ah. Okay. Oh no. Okay. Means cannot already lah. I think have to go back to sleep already. Cannot continue already the class. Oi, what do you mean by okay, good night? Okay, I'm back. Okay, 0.315. Okay, so here, you studying chemistry before my class? Oh my God. So good lah, you. You know what time I sleep yesterday? Not yesterday, you mean what time I sleep today? I sleep at 6 a.m. I almost cannot wake up just now. I set 10 alarms, you know. Okay, so here, okay, guys, see the ratio. The ratio. You love my class or you love me? Okay, so to find the number here, okay, ratio, okay, guys, we take it out, okay, we take it out like this. We take it out like this. Box ratio 0.315 2 to 3. We always find the box first. In order to find the box, we can use, I don't know what's this method called. Maybe it's called cross multiplication. Last time, yes, okay, last time my school teacher taught me one. Okay, we do cross multiplication. I don't know whether your school teacher, your generation still use the same method or not. So 3 times the question mark, I write 3, okay, what leh? 3x, yeah, x, okay, whatever, okay. Okay, I put a circle here, equals to 2 times 0.315. I get 0.63. You put A, can? Okay, then it is equals to 0.63 divided by 3. So, Yongxing, okay, thank you very much, Yongxing. So we should be able to get 0.21 for the box. So the box is 0.21. Oi, Yongxing, cannot delete message. Okay, 0.21. Okay, 0.21 in the box. Okay, then now we can find the x. Please help me to press your calculator. Help me to press your calculator. Hey, thank you very much. Wow, you're very good that way. 11.76 gram. Good. So there goes our warm up question. Warm up already, okay, warm up already. Now, hi Alice. Good morning, Alice. 你好. Okay, done. Any question for this page? 有问题吗？问题答的？Okay, 问题答的 very good. Go back to the notes. Our page number. G is the correct symbol. The unit, of course, is written here. What? Math is grammar. Okay. So in case, okay, I mean, in case any one of you doesn't know the unit for mass, okay, and other things, okay, mass has a unit gram. Okay, then guys, how about How about the relative atomic mass or any relative mass, relative molecular mass, relative formula mass? What's the unit for relative mass? Oh, you're so good. No need to have class ready lah. We go back to sleep. Okay, what's the unit, Sashimi? What's the unit for relative mass? Yongxing, Zachary, what's the unit for relative mass? Relative mass, guys. Why didn't at least, what's the formula? I mean, what's the formula? But what's the unit for relative mass? Very good. The answer is there is no unit. When you see the word relative, when you see the word, we don't care whether it's relative, atomic, molecular formula. There's no unit. No unit for relative mass. Tak ada. Then how about last one? Molar mass. If I see molar mass, what unit do I have to give? I have to write. Oh, very good. I clap for you all, can I clap for you all, okay? Gram per mole. Gram pula. Gram per mole. Very good. So this is all the units for mass, for different mass. All right. Okay, now back to the notes. Okay, let us look at page number 9. We are going through the experiment for the empirical formula. Confirm should come out. Okay, it's either they come out a small question like that one just now, or either they will come out one theory question regarding to the experiment, or maybe they can also, guys, remember, they can also come out in essay. If your exam this time, your midterm exam has essay, your teacher told you that it is a full format, most likely there will be one question. They want you to write the procedure. They want you to write the procedure of this experiment, the empirical formula experiment. The procedure, which is the report you all did in school. The whole procedure. But today we're not gonna do that one because I think you're so good, you all can memorize yourself one. So my job here today is just to explain, okay? The theory. Cannot then I also cannot help, okay? This is what everyone have to go through. Okay, in the page number 9, empirical formula of magnesium oxide, MgO. The most important theory for these two sets of experiment is you must know the difference between the experiment. Why are they two different methods to find empirical formula? I thought empirical formula is the same thing. Why can't we just use one experiment, one method to find everything? Why so mafan that they have to give us two different experiments? Okay, the reason is, see, in the experiment of empirical formula of magnesium oxide, magnesium is reacting directly. Yes, it is because of the reactivity. Very good. Correct. Magnesium here reacts directly with oxygen. This shows that magnesium is a reactive metal. When you hit the metal, and then it will burn themselves. It is called reactive. If I hit an iron, or your mom is cooking with iron or stainless steel wok, does it burn? No, it just becomes hot. Those are not reactive. So reactive metal, we can use this method, which we hit them and they react with oxygen directly to form magnesium oxide. Okay. And the most important result that we want to get or measure during the experiment is mass. like the first step we did just now. We want the mass, so we can find the empirical formula. So this is why before you start the experiment, you should measure the mass of the magnesium first. Not measure, like you have to weigh the mass of the magnesium first. Let's say I got 10 grams. Before I start the experiment, oh, I know that magnesium is 10 grams. After the experiment, you should know whether the mass will increase to a higher number or it decrease to a lower number. So guys, the 10 gram will go up to a higher number or it goes down to a lower number. Increase or decrease. The mass after the experiment will increase or decrease. Before experiment is 10. After experiment, higher or lower, increase or decrease. When I did the experiment, my group got a lower number, GG. Okay, so it's supposed to be a higher number because magnesium, it has reacted, it has combined with oxygen. Mg plus O, two things together now, supposed to be a higher mass. Let's say I got 12 grams. Okay. Once I got the 12 gram, I will be able to find the mass of the oxygen. So this is why in your lab report, you will record the mass like this. You make a table, right? The first one is for the empty crucible and lid, then the one with magnesium, and then the one with the product. So basically, you use this one, the magnesium oxide one, to minus off the magnesium so that you can get the mass of O. That is what we want. Okay? Can. So this is the first experiment for reactive metal. The red number is like here. Wait. Red number where is my procedure? My procedure missing away. Okay. Okay. Here. Okay, here, sorry, on top. Sorry, top, on top, sorry. So 1, 3, the red number are actually the procedure. Okay, I'm so sorry. It's up here. Okay, second experiment, page number 10. I was looking like, hey, where is my procedure? I thought those was like precautions that, okay, never mind. So the second experiment here, empirical formula for copper 2 oxide. This method is the method for those weak, not so reactive metal, okay? Which is metal that are less reactive than hydrogen. Yeah, so this method is for metal. They are less reactive than hydrogen. So we can do it this way. The experiment, you all did this experiment in school also? Did you all do this experiment in school? No. Also, teacher only let you all do this one. Skip. You all did this one, but without the CUO. Teacher say both experiment dangerous. Okay. I think you can change to other schools. Okay, because other school they all got to do this experiment. Must do one. Sashimi, your teacher cannot lah. We go report the teacher lah. Okay. Okay, so CUO. The second one is a bit harder. CuO plus hydrogen. So here's the difference. Just now that one is reacting with oxygen, but this one is reacting with hydrogen. The purpose of hydrogen here is to actually steal away the partner, steal away the girlfriend of the copper. See, okay, CuO is like a couple. Cu and O, boyfriend and girlfriend. So H2 decided to steal the O away and form Cu and also water. So this is the reaction. So you see, before the experiment, always measure first. Okay, let's say I got 10 grams for CuO. After the experiment, the mass will will increase or decrease. Okay, from CuO to Cu, of course, it decreased to a smaller number. Okay, let's say 8 grams. Then in order to find the mass of the O, we use the 10 grams to minus the 8 to get 2 lah. Can easy. So you also got a table like this. Ta-da! Good. So now, let us go through some precaution steps and then we will start doing the question at the back. So since now you already know this one, the heating one, okay, like cooking one, okay, cooking in a pot, okay, a small pot. This one is for reactive metal. When we are doing this experiment, we have to clean the magnesium ribbon with a sandpaper. When you're writing the procedure, let's say this one came out in the essay, and they want you to write the experimental procedure, you just have to imagine. Not imagine lah. Imagine. There's no better word already. You are doing this experiment like, hey, okay, that day in the lab, what is the first step I did? I use sandpaper to clean it. Then you just write. You just make a sentence. Clean it with sandpaper. Okay, then we have to, before we start the experiment, we have to weigh the mass and then we record down. After that, we will start heating the magnesium. Okay, basically we heat it with the lid open. We heat it with the lid open. Open because we want oxygen to go in. Okay, when you see the magnesium started to burn, when the magnesium started to burn, you have to, what do you have to do? Yes, when you see the magnesium started to burn, you have to close the crucible lid. You close it. Okay, you close it for a while. The reason is because when it starts burning, it will produce the white fumes. We doesn't want the product. The white fumes is actually the product. We doesn't want it to come out from the crucible because it is going to affect your final mass. So we close it to prevent it from coming out. And then after some times, we have to open again, open a little bit so that oxygen can go in. These are all the things they will ask you in structure. They will ask you like, hey, why do you need to open? Open is to let oxygen go in. But when it starts burning, we close it because we want to prevent it from escaping. And finally, so keep on repeating, right? That day in the lab, you all did the experiment. You have to open, close, open, close, open, close. Okay. Until it is like, oh, no more reaction. Then what we're supposed to do is we have to actually repeat the heating, cooling, and weighing process. heating, cooling, and weighing process until a constant mass is obtained. The meaning is when you see the experiment, the reaction like stop already, you go and weigh it. Got picture or not? Okay, no picture. Let's say this is my electronic balance. I weighed it. Maybe I got like I said just now, how many already are 10 grams. Okay, the first time weighing of the product, you get 10 grams. I know in school, because you doesn't have enough time. Once you got the result, then the teacher will be like, okay, class, can write down the result, close file. Okay. But actually, it's not like that one. You have to take this thing and put it back to heat again. Because whether it has reacted completely or not, we cannot tell. We cannot tell by looking at the substance. You have to keep on heating it. Okay. After like 1 minute, stop. We wait for the second time. And maybe this time, it will change a bit from maybe 10 or to, okay, 9.8 grams. When the mass change, me just now for the first time, the reaction is not, the magnesium oxide, the magnesium is not reacted completely yet. Okay, when I got a different number, I have to put it back to heating. So repeat, just keep on repeating. Heat it again for 1 minute. Okay, stop. Wait again. Okay, maybe this time I got 9.8. Heat again. Do one more time. Oh, okay. Oh, really? Okay, guys. After so many times, really, it's 9.8. Then that will be your final result. So in the school lab, those experiments your teacher did, most of them is like agak-agak on, okay. They just want you to like participate, then know what's going on, okay. But in exam, that time, writing answer is different one, okay. So remember to repeat to make sure that the reaction is completed. That's all. Okay, can Now, let's do the question at the back. Here. Where is it? Found it. Page 20. The number order wrong. No. It's just that I choose some like steps to explain only. Okay, here in the page 20, they are doing this experiment empiric. Where is my MgO one? 23. Oh my god. Sorry. 22. What's this teacher doing? Oh my god. Page 22. Are you still sleeping? Yes. Sorry. This is the experiment. Okay, this is the experiment. Yes. You're definitely better than me today. This is your first time seeing me teaching in the morning. Guys, do you know what time usually I wake up? Weekday. Yes, exactly. I sleep until 1 p.m. Like every day. So when I wake up in the morning, I'm like, my brain is still sleeping. Sorry, guys. Thank you very much. You wake up at 6. Oh my god. For what? Only old people wake up at 6 a.m. 2 p.m. you don't have class. Our class starts at 3:30. Normally our class start at 3:30. So I wake up at 1. Then I prepare lah, okay, prepare. Then I makan lah, okay, this and that lah, mandi lah. Then I reached the center at maybe like 3 something. Then 3:30 I teach. So okay, sorry. Back to this topic. Page 32. When I see it is hitting the magnesium directly like this, I know this for the reactive one. Okay. We got the mass already. So first, the definition. Okay. since we mentioned about definition, a lot of students will ask me like, hey, a lot of definition. Can you give me a definition list? I would say I don't really um I don't really think you have to memorize all the definition, guys. Because usually not many questions will come out, not many definition question will come out in the exam for chemistry. And then the way how they mark the definition is very strict one. Not like your physics. Like, oh, there's the concept there already, then they give you a mark. No. Chemistry, they want to see like exactly the same thing. One keyword missing, 0 mark. So don't waste your effort in memorizing the definition. There are too many definitions and they can ask you anything. If you can do, you do. But molecular formula and empirical formula, they are those one of the very popular definition to come out in the exam. Later, I tell you all what are the important ones. So for those who want to memorize, you will have like some important one to memorize. So molecular formula is the chemical formula that shows the actual number of what? You all help me with the answer. Molar mass, atom. Okay. Number of atoms, number of mole pula. Okay. Actual number of atoms of this one very important. Let's say you got everything correct already. You got everything correct already, but here you write the wrong keyword, then sorry. Number of atoms of each element in a compound. 1 mark. Actual number of atoms of each element in a compound. Okay. And also remember to write chemical formula that shows. Okay, guys. Please help me to do the empirical formula here. Do your mass mole ratio. Let's go. I wait for your answer. I wait for your answer. 加油. Yes, definition is like that one. You have to write everything just for 1 mark. One only. That's why I say not verdict. They have to start pressing my calculator already. Can show the meaning of empirical formula later. Later, then this one. Remember? The one that I said just now got empirical formula. Don't worry. Confirm other punya. Okay, no, I cannot stop. I cannot stop talking. Cannot stop talking. I have to talk. Otherwise, I fell asleep. What already? Oh, okay. Looking for MG. Okay, 39.7 minus 38.5. I get 0.8. 0.8. Is it? How is it? 0.8. Ah. Okay. I. 1.2. Thanks, Janelle. Okay, then continue with the next one. Yes, Yongxin, correct. You are right. Okay, then here this one, the 40.5 minus of the 39.7. Hey, guys, show them the working. Show them the working. Don't just write 1.2, show them the working. Some teacher, they like to see working one. Show them like, hey, see, I know how to do. So that's the answer. Continue, 1.2 divide 24. So the ratio is 1, 1. MgO. Yes, correct. MgO. And now, write the chemical equation for the reaction in the experiment. Okay, guys, write the answer into your book. Once you're done, you say, okay. Remember to balance it. Remember to balance it. Otherwise, no mark will be given. Write the equation. The one I showed you earlier on, when we go through the notes in front. Done. Thank you very much. And sorry. So Mg plus O2, we're going to get MgO. Ta-da! Okay, to balance the equation, hey guys, remember one very important reminder here. Never do your chemical equation like mathematics. Never plus things up straight away like, oh, Mg plus O2, MgO2. No, please don't do this. The proper way of how we get the product is you can get it here. You can either get it not working anymore. Okay. Hey. When I say important reminder, then my screen started to lag already. It's either you get the MgO from the empirical formula you calculated just now, it's back. Or you can use the ion Mg2 plus and O2 minus to combine to get MgO. To balance it, we write a 2 and a 2 here. Yes, Zachary, very good. Joshua, you're right. Hauser, very good. Next, why was the crucible covered with a lid as soon as the magnesium started burning? Why do you have to close it? Closing it is to prevent the white fumes of magnesium oxide from escaping. Yes, correct. We want to prevent the white fumes from escaping. Okay, they didn't ask the open one, but I will write it in myself. Why do I have to open? Okay, we have to open the crucible lid to allow oxygen gas to enter into the crucible to allow oxygen gas to enter into the crucible so that it can react with the magnesium. I actually cheated in the experiment. I just burned the magnesium. That's actually what I did last time also. Because we realized, I don't know whether you all have the same problem or not. When we do the experiment, we have been hitting the thing for like quite long, and then like, Why nothing happened one? We hit, then nothing happened one. Then we just take it out. We put here. When we see, oh, got fire already, only put it back. Like that. The reason is because the crucible in your school very lousy already. Too old already. Some of the students will even hit until the crucible until it breaks. So cute and small. Is it a new one? Does it look like a new one, or is it a very old one, very dirty one? Is it very white? Then maybe a very new one. Why is this method not suitable? To determine the empirical formula of copper 2 oxide, they always like to ask this kind of question, like, hey, why this method cannot be used for the copper 2 oxide? Which means they are actually asking you, why don't you do this Cu plus O2 and let it become CuO? The answer is it's not we don't want, but cannot. It's not we don't want, but cannot. Cannot. Tak boleh. Because the copper is not reactive. So when you heat it, it just becomes hot. It is not going to burn in fire. So cannot. So the reason is, okay, this is how we write the answer. Because copper is less reactive towards oxygen gas. Must write the word, okay, less reactive is not enough. Must write towards oxygen gas. This is the mistake I did last time. Oxygen only, okay, can, but must write towards oxygen. Copper react with hydrogen. Cannot, must write this way. So last time, I remember from 4 midterm exam, I write, because copper is a less reactive metal, 0 mark. Because the teacher say, I want to see the keyword less reactive towards oxygen gas. Next, explain on how to ensure. We still got 1 more hour to go. My God. Explain how to ensure that the reaction has completed. How you know that the reaction is already completed? How we know the reaction has completed? When there's no more white film. So I'm going to write, when there's no more white film. Get a bacon or bacaan. Okay. Oh, okay. Oh, until we get a bacon, I have to graduate. Okay, so okay, here, okay, guys. Remember, okay, yes. We have to repeat. Yes. Oh. Repeat. Must say repeat. They only want to see this answer, no other answer. Repeat. Heating, cooling, and weighing process until a constant mass is obtained.不能 fixed mass 不能。Okay, like this, guys. Sometimes they will do it the other way around and ask you, hey, guys, why do you want to repeat heating, cooling, and weighing process until a constant mass is obtained? Then your answer will be, it is to ensure that the reaction has completed. So that means sometimes this one will be the question, and this one become the answer. Next. two precaution steps that must be taken during the heating process. When we are, I mean during our heating process, this is our precaution step. These two are the answer already. Which means this is the explanation. Sorry, this is explanation. But what we have to write here is we have to open this one. Okay, and now you see, like crucible cover with a lid as soon as magnesium started burning. This question now become the answer. So which means we have to open and also close. So you just write open the crucible lid to allow oxygen gas to enter, and then we close it as soon as magnesium started burning to prevent the white fumes from escaping. Okay, can I skip the answer. Okay, one more question here, guys. One extra question. They also like to ask you, hey, what are the other metals other than magnesium? What are the other metals that we can also use the same method? Okay, they can use this MgO method. Wow. Hey, you all discuss the answer one. Why all of your answers same one? Got other answer. Okay, yes, I got aluminium. I got aluminium. Potassium. Try not to write potassium. Theory, okay. In theory, yes, potassium can one, but too reactive, so we avoid it. Sodium also cannot. Okay, so I give you the metals here. Okay, the way how I remember what kind of metals they are reactive, what kind of metals they are non-reactive. I got two methods here for you. One of the method is if you did work hard last year, Form 3, you all got work hard or not? Do you remember there's a list called reactivity series? The metal above hydrogen is zinc and so on. They are the reactive metal. Okay, but I know most of you doesn't work hard one. Last year, even you work hard, you also forgot already. So I normally use the second method, shortcut for lazy people like me. I just remember those metal they come with a 2, the Roman number, remember? Like you remember like copper 2, lead 2, iron 2. All these metal they come with the Roman number. Those are weak. Okay, those are non-reactive metal. So we'll give other metal without the Roman number, like it can be zinc, it can be calcium. You want aluminium also can. Since you all give me aluminium already, I give you something else. Okay, zinc lah, calcium lah, also can. Natrium cannot. Try to avoid sodium and potassium. A bit too reactive. Okay, then remember, those come with Roman number are weak metal. So when they ask you later on, go for all this. Copper, iron, lead. Okay. Next. Back to the page 20. Page 20, yeah. Do you all need a short break? Yes, no. Okay, a short one, okay, a short one, okay, a short one. Belum makan, okay. 5 minutes to sleep, no, I think not enough. Why not 50 minutes? Okay, please come back. 11, 7, 7, 11. Let's go. Bye-bye. Go to page 22 a while. Can, sure. This part. You want to screenshot the answer? Cannot. I don't want. Nah, can see. You're welcome. Ah, time's up, guys. So fast, right? I wish the break can we extend it until 12 o'clock. Okay, guys. If you okay, hi guys, can you all hear me? If yes, can you please send me an emoji in the chat? Hello, hello. I'm so excited. I'm so happy to see all of you here. Hello, 大家好，早上好。One more hour to go. Okay, thank you very much, guys. Let's go. Page 20. Let's look at the page 20. So in our page 20, this is the experiment to determine the empirical formula of copper 2 oxide. Hi, yes, hi. So what is meant by empirical formula? So empirical formula, okay, guys, I ask you, do you still remember what is, I don't refer to the one we did just now. What are the two words we have to write in the beginning? Something that shows. Something that shows. Very good. You're so good. Best. Chemical formula. Simplest ratio. Don't see. Where's Yongxing? Let me see. Yongxing. Okay, chemical formula. You go give me answer. No, ma. Where's your answer? Aiyo. Okay, chemical formula that shows the simplest ratio of number of atoms of each element. This one a lot. We got a lot of one. Of each element in a compound. Yongxing, very good. Best lah, Yongxing. Okay. People ask you the first two keywords, give you the last one. Okay, good. Okay. I see you all here already. I'm very happy. I didn't really expect like you all like will type out the answer one, because me myself, like when I attend a meeting also I do like that one. Like I do type anything. Okay, so okay guys, very good. What's so bad? Lazy ma. Okay, chemical formula. shows the simplest ratio of number of atoms of each element in the compound. Okay, simplest ratio. Then same thing, number of atoms of each element. No, it's not like I see the worst in you all. It's like I don't put the expectation too high, ma. Okay, how do you dry how do you dry the hydrogen gas? This is like my generation linear question, guys. Okay. First, okay, you have to know. Just now we say this reaction, this experiment is using hydrogen to steal away copper punya girlfriend. Steal the girlfriend. Hui. Okay, still like this. But where does the H2 come from? Oxygen, we know. Air got oxygen. But hydrogen, okay, this is why we need this part here. Hydrochloric acid and zinc is actually to produce hydrogen gas. So in case you all don't know, you all can write down. So this part is to produce hydrogen gas. Why not? We answer the question C first. Then later on, only you write this. The purpose of using zinc and hydrochloric acid in this experiment is to produce hydrogen gas. Okay, and then write a chemical equation. Can I have the equation, please? Thank you very much. Give me the equations, is it? Zinc and hydrochloric acid. Zinc and hydrochloric acid. Zachary, what are you doing? We want the equation for hydrochloric acid and zinc. At least very good. Hauser, very good. Sashimi, very good. Yongxing, you miss out something. Who is Sashimi? Is that the real name? Sashimi, someone asked you, is that your real name? She said yes. Her surname is Sa, and then name Shimi. Okay. So here, chemical equation is HCl plus zinc. And then, okay, here guys, to get the product, just like I told you, all right, okay, to get the product, we can actually do it this way. H plus and Cl minus is the ions, okay, from the HCl, and then zinc is Zn2 plus. We can always, okay, you have to know, if you still remember in the chapter 1, the definition of chemistry, do you remember the definition of chemistry? It is actually the interaction between different chemical substance. So interaction means we always trying to break them apart and pair them with a new partner. H plus and Cl minus, they were the partner in the reactant, like before the reaction. But after the reaction, we cannot have the same partner anymore. They must exchange their partner. So we have to break everything down and pair them with a new partner. So you think the Zn2 plus now will pair with the H plus or it pair with the Cl negative. If zinc is a positive ion, for sure, it has to pair with the negative ion. Can only positive and negative pair. Positive and positive cannot. LGBT is not allowed here in the chemistry. Okay, so H plus, yeah, so Zn2 plus and Cl minus, it forms ZnCl2. So this is how we get the product. New partner. Okay, while the H plus is now alone. Whenever H is alone, can we write H plus? The answer is cannot. We can only write H2. Okay? Just like that. Balancing the equation 2HCl. Now, back to this question B. They asked me, how do you dry the hydrogen gas? Let me see whether I also forgot already. Did I put the kind of question in? No, don't have. Got or not? Don't have. Don't have. Okay, actually last time in my generation guys, our setup of apparatus is different from your. Our setup of apparatus last time is not like this one. Our generation is not like that one. Okay, our generation one, it looks something like this one. Okay, first, yeah, we have the same thing here. Okay, in a container. Okay, let's say this is the container. And then it will be channeled into a U-shaped tube. In the U-shaped tube, they have some like drying agent. The drying agent will dry the hydrogen gas, and then only the hydrogen gas will be channeled into the tube with CuO. Okay, so this is like last generation one, okay, my KBSM syllabus. But sometimes, not very often, but sometimes the old generation teacher like me, they still like use those old questions, not updated yet their system. So they will use the old question. So if they ask you like, how do you dry? What we will say is we will pass, okay, we flow the hydrogen gas over anhydrous calcium chloride. So the drying agent is called the anhydrous calcium chloride. For me, I don't think this question is important, so I put a cross here after that. If your school teacher never like mentioned something like this before in the class, then just ignore it. Anhydrous is like drying agent, you know, like maybe when you buy a shoe, they will have a small packet of that thing. The substance is called anhydrous, which means it is a substance that can absorb the moisture. Like the silica something one, yes. It can absorb the moisture. Okay, that's called anhydrous. What can be seen after the oxide of copper heated strongly? Got a lot of different drying agent one. The one in shoebox is what maybe called Zephyr told me is what silica or gel something. Okay, so different things they use different drying agent. Maybe for food they use different one. Hauser. Okay, what can be seen after the oxide of copper is heated strongly? Okay, when they ask you what can be seen, it's actually the same as observation. Observation, they normally want you to tell them the color change. Okay, color change. Most of the time, observation, we will write color change. Okay, guys. For those who did this experiment before, or maybe your teacher did the experiment and show you all, do you remember what is the color of the CuO? What's the color of CuO? Chuo. Chuo. What's the color of chuo? Wow, you actually know it. Yes, the answer is black color. So what happened here is the black powder will turns. Wow, it turns into copper. Okay, you all can predict one. You see, predictable this one. Copper to oxide is black in color. But when it turns into copper, what is the color of copper? Have you seen a copper wire before? Have you seen a copper coin? Last time my generation, we got 1 cent, 1 cent. Orange, orange pula. The bronze color, okay, we call it brown. Okay, correct, guys, very good. Okay, turns brown. What's happening? Okay, turns brown. Okay, remember the black comes from CuO and brown is Cu. So black to brown. Yes, I can take a break now. Please do question donkey, guys. Thank you very much. You are the best. You are the best, go. Let's go. If the question got asked for 2 or 3 observation, what to write? For this experiment, they only ask 1 observation. Zephyr, faster calculate. Otherwise, I got no answer to copy or done already. Hauser, thank you very much. I love you, Hauser. Hauser even gave me the answer to copy. Yes, then I didn't even have to press my calculator. So to find or not, I mean, what? You gave me the number, meh? Okay. Okay, no, then not you lah, of course, then. Okay, so, so here, to find the mass of copper, we have to minus off 147.95 minus of 135.15 to get Hauser, what was that? 12.8. Correct one, no, Hauser. Later wrong already, they'll scold me one, 151.15 minus 147.95. I get what? 3.2. Huh? Hauser, you see? Hiya. Are you wrong? 3.2. Okay, sorry. My fault, Hauser. My bad. I mean, not my bad. Yongxing bad. Okay, so 3.2. Okay. Okay, so to find the mole, 12.8. Hauser, faster. What's the mole here? 0.2. Thank you. 3.2, 16. So ratio is 1:1 CuO. You're making him to do free labor. Yeah, I mean, like, I'm too lazy to do it already. Write a balanced equation for the reaction of oxide of copper and hydrogen. Guys, write your own equation, please. CuO plus hydrogen. Let's go. I give you 15 seconds. Okay, CuO plus H2. We get, wow, Hauser very fast. Cu plus H2O. Correct. Thank you very much, guys. Oh, you sent this answer 10 minutes earlier. Okay, yeah, you are the best one, exactly. Yes. So why does the hydrogen gas need to flow continuously for a while? Uh, I just realized, we forgot to go through the steps here, but it's okay. It's okay lah. Save time. We should away do it here. Hydrogen gas needs to flow continuously for a while before heating process. Okay, see before start heating, you must let the hydrogen gas to flow through the glass tube for a few minutes. Okay, guys, I have a question here. What is the color of hydrogen gas? Colorless, right? No color, right? Then how are you going to tell that the hydrogen gas is actually flowing? You cannot see the color also, then how you know the gas is flowing? How you know? Or just wait for a few minutes. We don't care, okay? Like we just assume God, okay, it's flowing. Okay, we just wait for a few minutes. Cannot determine. Okay, don't care. Okay. I found very good. Yes, we have to actually we can look at the water here exactly. You are right. You see, if there are gas flowing in, what will happen? You will see bubble. Yes. Blah, 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 blah. Okay, so this is like for you to check whether the gas is flowing or not. Okay, very good. So the reason why we do this is to actually remove. We want to remove the air that is already in the glass tube before the experiment. The reason why we do this is because, do you remember, there is a way for us to test hydrogen gas. To test hydrogen gas, we will have to use a kayu uji berbara. No, it should be kayu uji menyala, which we call it as the what? Matches. Flaming. Okay. Okay, I know. Okay, this wooden splinter. Yes, but what's the name of this wooden splinter? There are two types, guys. Hot wooden splinter. Got better answer. Okay, this one. Okay, smoking. Guys, this is not smoke. By the way, my drawing so bad, man. That one was fire, guys, not smoke. Okay, burning. Yes. Okay, burning is a burning wooden splinter, or it has another name called. My favorite answer is always lighted wooden splinter. Why? Because I'm too lazy. So I always got lazy shortcut for myself. To test hydrogen, I use the wooden splinter with the letter H. Lighted. Okay? H. Which means got fire, burning one. And then do you remember wooden splinter? There's another type of wooden splinter used to test oxygen gas. These are actually also all the things you all have to know. They will ask you one. I mean, maybe not now, but the second, I mean, the next exam after your midterm. To test oxygen, we use, yes, lazy method. If there's O, we use the wooden splinter with O. Yes, that is glowing. O and O, H and H. Okay, what happened here with the lighted wooden splinter is, if there's hydrogen gas, you put the lighted or burning wooden splinter, it produces a K-pop. Okay, good. So there'll be K-pop song playing. Dun, 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 dun. Okay, so pop sound. Okay, yes. Pop sound, correct. So the pop sound is actually a small explosion. So you have to remember, the mixture of hydrogen gas and O2 will actually cause explosion. Boom. This one pop sound because not much of the hydrogen gas, so it's maybe like pop, like that. But if there are a lot of hydrogen gas and there are a lot of oxygen together, you hit it, it's gonna be kaboom. So the reason why we want to remove the air is we want to prevent it from exploding. Boom. But not so serious. This one glass tube so small. It's not gonna hurt you, don't worry. Okay? So this is the first one. It is to remove the air in the glass tube. Why is there an air opening for the glass tube with water? Or this one? If we don't put the opening, then the pressure will be too high, lor. All the air is like, okay. Example, let's say you are drinking the packet drink, soya or what. Have you ever tried to blow into the straw? Then the things will what? The things will expand one, right? Like that. So you need like a hole for the air to actually come up. Okay, like that lah. So can the empirical formula of magnesium oxide be determined by using the same method? Of course cannot. No. Why magnesium cannot use this method? Why? Remember, this method is stealing girlfriend method. So they're actually asking you. They're actually asking. Why don't you use MgO to react with H2 so that H2 can steal the girlfriend and make it Mg like that? It's not we don't want, but cannot. Okay, cannot because magnesium, yes, magnesium is more reactive than hydrogen. Correct. Very good. Must compare it to hydrogen. We want to tell them that, hey, you think everybody can steal away my girlfriend? So not all, it's not like hydrogen can steal away the girlfriend of everything. Like, okay, example like me. If I say I want to like steal away, I don't know, got what example? Hauser say, if I want to steal away Zachary's girlfriend, okay. So let's say if I want to steal away someone's girlfriend, I has to be better than the guy. So let's say Jay Chow, I don't know, my generation is Jay Chow, guys. Let's say I want to steal away the Jay Chow's girlfriend or wife. Do you think it's possible? No, cannot. Okay, cannot. But if Jay Chow want to steal away my girlfriend, can or not? Can. So whichever, Yong-Sing. So whichever is more reactive, they can steal away people's girlfriend. This is how it works. Okay, continue. The hydrogen gas is allowed to flow until the product of heating is at room temperature. Okay, guys. Before the experiment, we let the hydrogen gas to flow. After the experiment now, okay, done already. Once it is done, we still let the hydrogen gas to flow. Just keep on flowing. Just keep flowing. Don't stop, guys. Why after the experiment you still want to let the hydrogen gas to flow? No more fire. You put out the fire already. Yes, Xiaoyi, you're right. The reason is because we want to prevent the air from entering into the glass tube and then react with the hot copper again. The product, the copper here, produce is still hot, if it contact with some oxygen, maybe some of them will have reaction. So we want to prevent this from happening. So our answer will be to prevent oxygen gas from entering the glass tube and react with the hot copper. Why use the ethanol? Okay, this one we call it the spirit lamp. We use this one is because the heat is not that high like Bunsen burner. We don't use Bunsen burner is because the heat is too much, too strong already. It can break the glass. This glass tube is very thin one. If you use Bunsen burner, it breaks very easily. Xiaoyu, to be exact is magnesium cannot have oxide. Okay, magnesium more reactive than hydrogen, and then copper less reactive. The Bunsen burner is for more intense heating, like when I want to heat Euler Hauser, then I use Bunsen burner. Why do the heating, cooling, and weighing process need to be heated until a constant mass is obtained? So guys, they ask you, why do you have to repeat this step? It is to ensure the reading is accurate wrong. Get accurate result wrong. Yes, Xiaoyu, you are right. Yes. Nisha, you are right. Very good, Nisha. Yes, Hauser correct. It is to ensure that the reaction is completed. Or you can say, okay, there's another way, writing the answer, see which one you all prefer. To ensure the copper to oxide has reacted completely, also can. Where they all got the answer? Just now I already can't. Hey, guys, this student ask you all like, hey, how you all know the answer one? Huh? How come she don't know the answer? I thought just now I already told you all, right? The question and answer can be terbalik one, right? If they ask you, hey, why have to do this? Then the answer will become this one. Not listening, hush. Okay, this one. Done? Or they are too quick with the answer. Yeah, I don't know why are they so excited already. Chill, guys, chill. Yongxing ask you all to chill. Slowly. Okay. Okay, done. Any question, guys? Is there any question you want to ask me? No, okay. Afterwards, if you have any question, Hauser, this one, Hauser, don't simply type. This one I cannot read out. Okay. So what I want to say is, if you have any question afterwards, you can WhatsApp me. Okay, you can WhatsApp me. For those who doesn't have my number, you can your IG inbox me also can lah. Okay. For those who do know me lah. Okay, I don't know whether there's new student here or not. Okay, guys. Now we have to look at page 15. Page 15. My IG is Wailun __. Just my name, okay? So 15. Okay, page 15. Chapter 2. Don't follow me. I mean, like now we do this one first, please. Okay, page 15. Okay, thank you very much. Okay, So page 15, chapter 2, guys. Chapter 2. In the chapter 2, please remind me later to give you the, like to tell you what are the very important definition to study, okay? So state the meaning of isotope. Isotope. What is isotope, guys? Can anyone tell me the meaning of isotope? What is isotope? Oh, hey, how come you all like know what am I going to ask? How come your answer is so ready? Like I just finished asking the question, then the whole answer came out already. My God. Okay. So okay. Okay, don't write first. Don't write first. Yongxing, you good? Yongxing? Okay. So a lot of students will be giving me they give me answer like same proton but different uh neutron like this cannot. You must write the complete one, including this one, atoms of the same element. Because as I told you, isotope, okay, what is isotopes? Isotopes, they are like siblings. Siblings means they are people that come from the same family, people of the same family. So element is like family. So atoms, they come from the same family. Okay, if they are siblings, they're gonna have same DNA. The DNA for atoms are actually proton. Proton is being locked inside the nucleus, guys. So atoms of the same element with the same proton number but different nucleon number. With same proton number but different nucleon number. Okay, for those who prefer to use the word number of proton, you must pair it together with number of neutron. Number of pair with number of. Proton number pair with nucleon number. There is no mix and match. If you do mix and match, 0 mark. I can't write with the same proton number but different number of neutron, cannot. They also reject different neutron number, which means there's no other things you can write. Proton number, nucleon number, or number of proton, number of neutron, that's all. Nothing else. Definition. Okay. Determine the number of proton of a sodium-23 ion. In this week, we did the periodic table, right? And then when we are doing the periodic table part, we did mention something like this before. The number on top is showing the nucleon number, while the number at the bottom is showing proton. So when they ask me proton, then it will be 11. State one use of 2411 Na in daily life. Okay, one question, guys. What is the name of this isotope? What is the name of this isotope? What's the name of this isotope? Ooh. Okay lah, we can dismiss the class earlier already. Everyone can do. So good. Na is sodium. The way how we name an isotope is always the name of the family, sodium, followed by the nucleon number. In case you all don't know, this is the nucleon. So the name it is called sodium-24. Sodium-24 is used to detect will they accept natrium-24? Natrium-24 is only accepted for the BM version. To be honest, natrium-24, nothing is wrong. There's nothing wrong with natrium-24. But a lot of the school teacher, especially those lousy school teacher, they will just follow the marking scheme. When they see all the answer, the keyword different, the word different, then they straight away mark you wrong already. Because they cannot tell whether it's correct or wrong. They don't know one. They just follow the scheme. So it's to detect the leakage in the underground pipes. Must write the word underground. Because if the pipe is not in the underground, you do have to use this one. Okay, then draw the atomic structure. How do you know these keywords? You mean like how do I know what are the keywords to write, is it? Like how do I know must have underground and stuff? Let me think first. Okay, let me think. Memorize. Okay, memorize. Okay, memorize and also plus a bit of logical thinking, okay, or common sense. Because if the pipe is not in the underground, then we do have to use this to check. Okay, and like some of the keyword here, it's like maybe last time I made the mistake. And then I learned from the mistake. Oh, actually I have to do it this way. Like that. So draw the atomic structure, guys. For sure, they will ask you all to draw one. Draw is either they ask you to draw atomic structure or they will ask you to draw electron arrangement. Is atomic structure and electron arrangement the same thing? No. What's the difference? What's the difference? Wow. Hey, you're so smart one. How come you, I wanted to ask the same question, like, how you all know the answer one? Because last time, last time when I was Form 4, I cannot tell the difference one, guys. Okay, so here, very good. For atomic structure, okay, you all win already. Okay, win already. Clap for you all. Very good, really good. For atomic structure, we have to always show all the subatomic particle. All the subatomic particle. Very good. Means must have proton, electron, and neutron. Everything shown in the diagram. So Na is having 11 proton and 12 neutron. Sashimi, you good? Okay, then the electron arrangement. Yes, you are drawing. Okay, just checking. So 2, 8, 1. Wherever you want to place the 1, you don't care. Okay. And then please remember, guys, if you can use dot if you want. If you doesn't want to use cross, you can use a dot. You can use dot But don't use the circle like that lah. You can use dot. Okay, guys, remember, if that substance, guys, if that substance, let's say, it is 13 proton, 283. This is how you draw your 283. 3, 1, 2, 3. Which means every side must have one electron first before you repeat it to make it a pair. 4 electrons here. Your teacher want clockwise. I clap for your teacher. Okay, it doesn't matter one, guys. You put here like this also can, you put here also can, where you want to put like, as long as there are 3, one of the side has 1 electron. If got 4, then here. 5 only you repeat. 5, 6, 7. Remember, okay? So this is just an example. And then for electron arrangement, it's the same thing. You're just like, you click copy and then you paste here. You paste, then you erase the middle one and write Na. Done. Any question? No, So the middle part is different. Very good. Table 1. It shows the proton number, nucleon number of 3 different atoms, and blah, blah, blah. Okay, what is mean by nucleon number? Nucleon number is the... You want to try? Want to try? Want to try? Not 13 neutron. Oh my god, 13 neutron. Yes, guys, I'm sorry. It's 13 neutron. Hiya, who wrote 12? 13 guys. Because 24 24 minus 11. Hauser, why you never check the answer for me? Okay. Nuclear definition for nuclear number, guys. Sorry. My bad. Ask Zachary. Hi, Zach. Yeah, lah, never check for me. Oh, Nisha, very good. Oh, Zach, very good. Okay. Joshua, very good. No, ask Jia Yuan. Who is Jia Yuan? My friend, where? Got Jia Yuan, meh? Hi, Jia Yuan. I mean, yes, hi, Jia Yuan. Oi, bro. You didn't even give me one answer. How am I going to know you are here? Like, now he's like, he give me 3 dots. Like, I asked, is got giant man? Then he like, dot. Okay. Hi guys, don't like that. Okay, the answer for nuclear number is the total number of proton and neutron in the nucleus of an atom. One word missing, kosong. Especially in the nucleus, your teacher will be very sensitive to this one. In a nucleus, don't know. Inter is the best. Okay. The number of neutron, my one acceptable. Cannot. Must be total number of proton and neutron in the nucleus of an atom. Nothing else. Definition, right? State the number of neutrons for atom V. Atom V, this time I pro already, I know. 24 minus 12, I get 12. Learn from the mistake. State a pair of isotope. Explain your answer. So isotope must be our atom T and U. Why? Just like the definition. Because atom T and U have the same proton number but different nucleon number. U in the daily life, this is sodium 24 again. This is sodium 24. By the way, if your coming exam has chapter 4 periodic table, if you ask me like, hey, how do you know this is sodium? Periodic table. Okay, periodic table. If your exam doesn't have periodic table, they won't ask you question like this. Okay, because student can actually check like 11 and 11 proton is which element. Then you will be able to find Na here. So it's a sodium. And then the name is called sodium 24. Okay, next. Last ready. Okay, every time when you see question giving you keyword, I know it's the use, same as the one just now. Then the detect the leakage in the underground pipe, same thing. Same thing. Okay. I didn't write, I skipped, sorry, I skipped the answer here. Okay, then every time when you see abundance, which they gave you percentage and want you to find relative atomic mass. When you see percentage, when you see isotope, and they want you to find relative atomic mass, for sure, this one will be just finding the average mass of all the family member. So they told me that silicon 28 is 92%. So we just times it, times 92% plus silicon 29 is 5%. And lastly, silicon 30 is 3%. And then divide 100, yes. To get 28.11. Very good, Ayo. Hosh. What is the unit? What's the unit? What's the unit for this mass? Very good. Very good. Oh. Okay. Isotope are widely, there's no unit by the way. Yeah. Isotope are widely used in different field. State one example of isotope used in medical field. Medical, we got two examples, guys. Medical. Cobalt 60. Okay, the most popular one, cobalt 60. And then after that, it will be the iodine. 你们又懂? My God. How? Like how? Iodine 131. Jia Yuan, why you never give me answer, Jia Yuan? So, cobalt 60 is to treat, it's to treat cancer. Oh, Hauser, quite smart. Okay, treat cancer. Hauser has all the answer already. Oh, okay. Jaren said Hauser got all the answers, so he didn't have to give the answer. Okay. Treat cancer or to sterilize? Surgical instrument. Instrument. Is it called instrument or equipment, guys? Surgical tools also can. Why when I write instrument, I got musical instrument? Okay, so next, iodine 131. It is to treat, yes, the thyroid. Diseases, okay, or thyroid disease lah, okay? So just like that. So before I let you go, let me write down some important definition that you all must remember. Okay, definition. Always leave it as the last thing to study, guys. Don't do your revision by starting with a definition, not verdict. Okay, first one must be our empirical formula or molecular formula. Okay, these two are. Okay, this is for chapter 3. And then for chapter 2, they like to ask, of course, they can ask other things like, hey, define mode, define Avogadro's constant. They can ask you just anything, but these are the most popular one. Empirical molecular formula. Okay, in the chapter 2, they like to ask melting and boiling point. They like to ask nucleon number, proton number. They also like to ask isotopes. That's all lah. If it comes out, it comes out. If no, then proton. What's the definition of proton? Proton number is the number of proton in the nucleus of an atom. Okay, so these are the popular one. If they come out, they come out. If no, then just whatever lah. Try your best lah. Okay. Chapter 4. Oh, you all got chapter 4. Okay, chapter 4. They like to ask you to define period and group. One is horizontal row, another one is vertical column in the periodic table of element. And yeah, that's all. That's all. Okay. Thank you very much, guys. Thank you. Okay. Thanks for answering my question. Yeah. Thank you very much, guys. See you next week, next Wednesday. Vertical column. Okay, that's all for today. Bye-bye. Thank you very much. Bye-bye. 再见. Good night. Okay, guys. Good night. Good night. Time to do chemia homework. Hiya. Time to sleep, bro. Okay, bye-bye. Good night. Good night. Bye-bye. Bye. Good night. Bye, Zachary. Bye-bye.